Now let's look at hydrogen. Okay, since hydrogen is one of the other products or elements it's made of, we know that it's a gas. Oops, let me go back. Get my pen. So we know it's a gas. It will burn in the presence of oxygen because the sun is hydrogen. You can't see it. Oxygen is a colorless gas, and you can't see that either. Okay, so this chemical change that we have when we burn sugar is we actually make water. Now, water could put out fires, right? Whereas hydrogen and oxygen are oxygen is necessary for fire, and hydrogen is flammable. So, totally different properties. Now, let's look at another common compound. First, we'll start with the elements that make it up. Sodium. Sodium is a metal. It's very soft and it's gray or silvery. Okay. We usually store it in kerosene. Now, that's interesting. Why do we store in kerosene? Well, sodium plus water catches fire. So you don't want to have it anywhere near water. So kerosene is an organic chemical. That means it has lots of carbon in it, and it's non-polar. All right? And since it's non-polar, water doesn't easily get near the sodium when it's stored. So the water won't, get near the sodium. The sodium won't catch on fire. Now we'll learn later on why that happens. It has to be the reaction that occurs with sodium and water. We'll talk about that much later in the class. Now, chlorine, on the other hand, at room temperature, is a pale yellow poisonous gas. Okay? So it's yellow. Oops. And key part is poisonous. You should know that because if you ever go to a swimming pool, in a public swimming pool, they might have gas tanks of chlorine that they use to kill bacteria and funguses and all sorts of materials in the pool so you can swim in it without getting sick. But if they had let the gas out, that would be very dangerous to the people in the area because it's poisonous to people in higher quantities. So when these two things combine at a very high temperature, they produce table salt, which is called sodium chloride. So sodium and chloride combine to form a new compound which has different properties and different structures or composition. Okay, one thing we could say is we know that table salt is a white solid. It has a very high melting point. We know it tastes salty, for lack of a better term. All right. We know chlorine is a yellow poison. We wouldn't want to eat that. And sodium starts on fire if it gets close to water. And your mouth has lots of saliva, which is mostly water. So your mouth would be on fire. That doesn't happen with salt. So it has totally different properties. Very, very important thing. Compounds have different properties than the constituent elements that it is made of. Okay, once again, can elements be broken down by chemical changes? What about compounds? Elements? Right. Absolutely not. Compounds, on the other hand, can be broken down into the elements or other compounds. Okay, so you cannot break down an element. Compounds can be changed by chemical changes. Okay, now we've got pure substances and we have mixtures. We want to know now how we can distinguish between the two if you're giving a sample. It can be very difficult because we learned that homogeneous mixtures look uniform throughout. So a solution or a homogeneous mixture is going to look very similar to a substance. Okay, but it's not. So we have a challenge to find out which one is which. Okay, sometimes you can consider based on your knowledge of the material you're looking at. For instance, if we were going to look at milk, milk can be made non-fat, skim milk, 1%, 2% fat, whole milk, cream, heavy cream, light cream. Okay, you have all these choices, and they're all from milk. Okay, so if you can say that, okay, you have different types of milk, so it's easy to conclude that milk is a mixture, because whole milk has heavy cream in it too, or light cream at least. So they basically have, and cream, heavy cream is almost pure fat, so the difference is the amount of fat. So fat is different than the water that makes up most of the milk. Okay, what about gasoline? That's another thing you can pretty much infer from, because you can buy 87 or super that might be 91 octane, which means they're blends. They're different amounts of things in the gas tank. So right there, you know it's a mixture from that information. You also, if you read next to the gas pump, sometimes it says detergent added. Well, detergent isn't gasoline. It's something to keep your engine clean, so therefore there's something else in it. So gasoline must also be a mixture. Okay, that's just thinking about what you know about gasoline, okay? That there's different types, so if the composition is different, then that's a clue that you have a mixture. A substance is going to have the same composition no matter the sample of the substance that you have. So, to summarize that, if the composition of a material is fixed, that means there's not options like in gasoline or milk. The material is a substance. If the composition can vary, then it's a mixture. Composition is fixed, compound or element, which is a substance. Composition can vary. You can have 2%, 3% milk. Well, I don't know if you have 3% milk. The material is a mixture. Okay? All right, here's a nice chart, that kind of a flow chart that we have. Okay, if something is matter, and everything that is around us is matter, except for things that are pure energy, so we ask ourselves a question. Does it have a definite composition? That means, is it homogeneous? If you say yes, okay, then you can either have an element or compound. You know it's a compound if it can be separated chemically. Okay, if we go down this path, if we think we have a mixture, we have variable compositions which can be separated physically into substances. And there's two types of mixtures. One is homogeneous, which is uniform throughout. We also call that a solution. Or heterogeneous, non-uniform, distinct phases. Okay? So it's either you can either see the different parts to it, like salt and pepper mixed together, or you have oil and vinegar, where you have two phases. So you can ask yourself, if you're trying to look between a mixture and substance, is if the mixture can be separated physically, then we know it was a mixture. But what is it being separated into? It's being separated into a substance, which is a definite composition, and that substance can either be an element or compound. If we can separate it into smaller components through chemical means, then that was a compound. If not, it's an element. Okay? So you might want to take a screenshot of that and put that in your OneNote notes. This is a good flow chart to separate the parts of matter. So matter is made up of substances and mixtures. The substances are elements and compounds. The mixtures are homogeneous and heterogeneous. All right, let's go through this question and answer it together. We have a blue-green solid and it's heated. When it's heated, we get a colorless gas and a black solid. All three materials are substances. Is it possible to classify these substances as elements or compounds? So the question tells us that all three are substances. So that means they either have to be a compound or an element. Okay, so we're heating something and we're getting something different. Well, that implies that if we get a totally new substance that has different properties, so we had a blue-green solid and we get a colorless gas and a black solid, that's different properties. So we must have started out with a compound. Yes, that's right. We started out with a compound. Okay, a compound can be broken down into simpler substances. That's what happened. But an element cannot. And when we heat something up, that's one of the things we can do to start a chemical change. So heating can cause a chemical change. So we can say that the blue-green substance, when heated, produces two other substances. If that's the case, what can we say about the blue-green solid? Well, this is what it made. So before there was one substance, after heating there was two substances. So the blue-green solid must be a compound, because it made two substances. However, we cannot determine with the information given if the two new substances are elements or compounds. Okay? So based on the information, we don't know if further testing is necessary. All right, here's another scenario. You have a silvery liquid. It doesn't seem to change at all. Is it a substance or a mixture? So if it's not changing and you do all sorts of things to it, try to boil it, try to heat it, nothing happens. So basically, you're pretty close from that information saying that that is probably most likely a substance. Because you could have tried to separate it, you could try to manipulate it chemically or physically, still nothing happens, so it's probably a substance. Okay, so now we've got elements and compounds and mixtures down. How do we represent these things? So elements and compounds are represented by symbols. And we're going to talk about where you can find those symbols and how these symbols started. So we use something called chemical symbols. And we have a periodic table that have all the symbols on them with the names, so we can remember what these represent. Now, how we make compounds is we combine these symbols to represent the elements contained in those compounds and use subscripts to tell us the proportions by which these elements have been combined in the new compounds. Now, just to go over, the chemical symbols usually are either something like a single uppercase letter, like hydrogen, or the first letter is always uppercase and a second letter is lowercase, something like helium. Now, you may sometimes see at the very end of the periodic table something that has three letters. This is not an official name. It's a compound that has been recently discovered and has not been verified yet. So they give it a 3-letter temporary name, which basically qualifies it in Latin as a number. Okay, and we'll go into deeper detail as we talk about the periodic table. So an element on the periodic table will either be a single uppercase, have a symbol represented with a single uppercase letter, or 2 letters, the first one being capital, the second being lowercase. All right?